The first solution, setting the text direction for each widget, can be tedious in larger apps with many screens and widgets. A more efficient approach is to use a widget like Material App, which automatically handles directionality and other default behaviors for the entire widget tree. Material App is the foundation of a material design-based app and provides essential features like text direction, theming, and routing. The home property defines the app's initial screen, similar to the home page of a website. In our example, the home is a scaffold, which provides a basic layout with two sections, the app bar for the title and the body for main content. Now, the widget tree is structured with a material app wrapping a scaffold, which contains an app bar and the center widget. This more realistic setup provides a clear foundation for a full app, even though real-world apps often have deeper widget trees. When running the app, you will see two text elements, one in the app bar and one centered on the screen. Thanks to Material App, the system locale and the layout direction are automatically applied. Additionally, the appearance changes. The default theme gives us a white background with black text instead of the previous black background and white text. This theme system allows for consistent styling across the app, which we will explore further later on. In this updated version of the code, there are two key changes. First, the debug banner that appears by default in the top right corner during development can be removed. If you would rather don't see it, simply set the debug show checker mode banner parameter of the Material App constructor to false. Its default value is true. Second, I'm running the app on my Android emulator, even though I usually work with an iPhone simulator. On Android, the app's title in the app bar is left aligned by default. Keep in mind that Flutter automatically handles the compilation process based on the selected device, so we don't manually compile for each platform. Another change is in the text widget. Instead of just showing Hello World, we are styling the text using the style property. This requires a text style object where we have set the font size to 30, the font family to Arial, and the text color to deep orange. Of course, you can choose any color, and the color classes offers a wide range of predefined options. Now that we have a clearer understanding of our first simple app, let's take a closer look at widgets. In Flutter, widgets are specialized classes that define the core building blocks of the user interface. The objects created from these classes are immutable and represent the structure and behavior of UI elements. However, widgets don't dictate the exact position of elements on the screen, as this is influenced by device-specific constraints and the layout. Likewise, widgets don't define the appearance, as that is controlled by the active design system. The actual rendering process is managed by Flutter's rendering engine. When updates occur, Flutter optimizes performance by using a smart re-rendering system, which calculates the differences between the current and updated widget trees and only refreshes the parts that have changed. As mentioned before, every graphical element in Flutter is a widget, and the framework follows a classic object-oriented inheritance structure. At the top of this structure lies the abstract widget class. From there, widgets split into two primary categories, stateless and stateful, represented by the base classes stateless widget and stateful widget, respectively. Beneath these are numerous specific implementations. The leaves of the hierarchy, consisting of many predefined stateless and stateful widgets provided by the Flutter library. When you use built-in widgets, their types and behaviors are predefined. However, when creating your own widget, you need to decide whether it will be a stateless or stateful one. This decision affects how the widget manages its internal state and interacts with the UI. All widgets in Flutter have a state in a broad sense, but there is an important distinction. The state of stateless widgets is fixed after they are built, while stateful widgets can manage and update their state throughout their life cycle. For example, the position of a slider or whether a checkbox is checked can change during a widget's life cycle, and these are pieces of dynamic state. Since widgets in Flutter are immutable, stateful widgets rely on separate objects to handle state management. As a result, a stateless widget is defined as a single class that extends stateless widget, while a stateful widget involves two classes: the widget class, which extends stateful widget, and the state class, which extends state t, where t is the type of the widget. This separation allows the widget state to update without affecting its immutability. The official Flutter widget catalog offers a detailed overview of the many widgets included in the framework. It features the two primary style systems, Cupertino, which provides iOS-style widgets, and Material, which delivers Android-style widgets, alongside a broad set of functional widgets used to build nearly every part of a user interface. While this course won't cover every widget available, we will concentrate on a core set that illustrates the key principles and workings of Flutter's UI system. The catalog itself is an excellent reference, offering in-depth descriptions, usage instructions, and examples for each widget, making it a great resource as your app development needs to expand. Given the many alternatives, let's focus on some fundamental UI elements in Flutter. Starting with the text widget, which we have already used, it displays strings on the screen. Next is Scaffold, a fundamental widget that defines the main layout structure of material-style apps. Flutter also includes several button types. Elevated button is just one of the many available options. You will also work with image and icon widgets, both of which are straightforward and serve visual purposes in the UI. Some of the most essential widgets in Flutter are those used to build layouts by combining other widgets. For arranging elements horizontally and vertically, we use row and column, respectively. The direction, left to right or top to bottom, is determined by the device's text direction, as discussed earlier. There is also the stack widget, which enables you to place widgets on top of each other, effectively adding a third dimension, the z-axis, to your layout. Lastly, we have the versatile container widget. It's essentially a box that wraps another widget, but it's extremely useful when you need to apply size constraints, padding, margins, or background colors. For example, if you want to change the layout or look of a text element, placing it inside a container gives you more control. The problem is now how we can compose them to create proper GUIs.